Hello students, welcome you to this video. In this series, we are discussing the concepts and some of the very important questions, right? So we are studying limits and continuity. So in this video, we are going to study infinite limits and limits at infinity. Infinite limit, when you find the limit, your answer may be plus infinity or minus infinity. So when you give infinity, something by zero is infinity. But if that something is positive, your answer is plus infinity. If it is negative, minus infinity. They are not same. In the case of zero, whether it is plus zero or minus zero, both are same. But in infinity, plus infinity and minus infinity are two extremes, right? So they are not equal. You have to be very careful. So please listen here. And suppose x is tending to 2. X is tending to 2 means, right limit and left limit. It may approach through left side, that is left limit. It will be right 2 minus, right? Slightly less than 2. Slightly less than 2 means it is 1.999, something like that. Right limit approaching through the right side. So slightly more than 2. So 2 plus 2.0001. Then in that case, suppose x minus 2. So whether it is positive or negative, when the case of left limit 1.99, if you give 1.99 minus 2, your answer is greater number is negative, your answer is negative, right? If I give 2.0001 minus 2, greater number is positive, your answer is what? Positive. So it makes some difference, okay? And in quadrants also, see, this is 0, this is 90. 90 plus means it will come here. Second quadrant, only sign is positive, other ratios are negative. 90 minus means it will be in the first quadrant. 90 minus 89.99, whatever it is. So it is in the first quadrant only. Slightly more than 90, 90.001 something degree like that. It is in the second quadrant. Okay, it changes the sign. So plus infinity, minus it makes huge difference. So be very careful in this one. Okay. Then next we study limits at infinity. Limits at infinity means limit x tending to infinity. Okay, that type sums also we are going to study. Here you must know how to factorize, how to take the common value outside. If it is x square minus 2x, easily you can take common value. You can see common x, take x outside, you will get what? X minus 2. But suppose x minus 2 is given. You say nothing is common. Yes. Suppose if I want to take x common, you can take it. What will happen? 1 minus 2 by x, right? You will get 1 minus 2x, 2 by x. Suppose you have x square minus 7x plus 6. Highest power of x is x square. X square is not common, but still if I want to take x square common, you can take. What will happen, x square we taken out, so it become 1 minus 7. X is there, but we are taking x square outside, so shortage of 1x, so right, by x. Plus next we have only 6. X is not there, we are taking x square outside, so x square shortage, write that x square here. If you have a doubt, you multiply and see, you will get it. So why we are doing like this, for these type of questions, n tends to infinity or x tends to infinity, something by infinity, the answer 0. When you apply the limit 7 by infinity, this will be 0. 6 by infinity square, it is in 6 by infinity, it is 0. So 2 by infinity, it is 0. So for that purpose, we take it outside, okay? So with this little idea, so we are going to do exercise 9.3, some questions, and finally I'm going to teach some statement sums also, okay? Look at this question. Here actually the question is, find the left and right limit of the function, 2 subdivisions. I'm taking the second one. So they asked to find the right limit and left limit. So first let us find the left limit. So that is f of at pi by 2, right? So pi by 2 minus. So limit x tends to pi by 2 minus f of x. What is f of x? Tan x. So actually you are going to apply the limit pi by 2 only, whether it is pi by 2 plus or pi by 2 minus. For x you are going to give the value pi by 2. So tan pi by 2, tan 90 is infinity, but we are very much interested to see whether it is plus infinity or minus infinity. So please listen here. Pi by 2 minus pi by 2 is 90. Pi by 2 is on the line. Pi by 2 minus will come back slightly. Whatever it is in the first quadrant. Okay, pi by 2 minus slightly less than 90. So it is in the first quadrant. First quadrant tan is what? Positive. All the ratios are positive. So you give tan pi by 2. So okay, you are substituting tan 90. It is infinity. It is plus infinity because it is in the first quadrant. Now let us find the right limit. That is f of pi by 2 plus. Okay, so you find f of pi by 2 plus. So you find limit x tends to pi by 2 plus f of x. F of x is what? Tan x. F of x is what? Tan x. Slightly more than 90. 90 means on the line. Pi by 2 plus, even if it is very small, it will come to the second quadrant. Second quadrant, only first quadrant, all the ratios positive. Second quadrant, only sign is positive. So tan must be negative. When you give 90, tan 90 infinity, your answer is what? Minus infinity. The reason it is in the second quadrant. Right limit and left limit, they are different, so limit does not exist. Okay, so this is how you have to do that. Okay, now let's see the next subdivision. Find the left and right limit of, see, a lengthy question, f of x equal to x square minus 4 by x square plus 4x plus 4 into x plus 3. At x equal to minus 2, please listen very carefully, x is equal to minus 2. When you find the left limit, slightly less than minus 2, very careful here, minus 2 here, this will be minus 3. Slightly less than minus 2 means minus 2.0001, something like that. Then right limit means it approaches through this side. This is minus 1, it approaches through this side. Okay, so this is right limit, slightly more than minus 2. More than 2 means 2.1, right, 2.001. But here, more than minus 2 means it is something like this, minus 1.999, something like that. Okay, be very careful in this one. Okay, so first you find the left limit. For that you find f of minus 2 minus limit x tends to minus 2 minus f of x, it is x square minus 4. 4 can be written as 2 square, right? You can factorize. Okay, we do the next step. By x square plus 4x plus 4 into x plus 3. First you factorize and you cancel whatever you can. Limit x tends to minus 2 minus a square minus b square. 4 can be written as 2 square. So x plus 2 into x minus 2. By here the first one, x square plus 4x plus 4, a square plus 2ab plus b square, a plus b the whole square, x plus 2 the whole square into x plus 3. We are giving the limit x tends to minus 2 plus or minus 2 minus. Okay, we are not giving exactly minus 2. So it is slightly more than 0 or less than 0. So you can cancel it. X plus 2 cancel one time. Now we are going to apply the limit. For x you give minus 2. So minus 2 minus 2 minus 4. For numerator no problem. Denominator second factor no problem. You give minus 2. So minus 2 plus 3 it is 1. The problem is here only when you give minus 2 plus 2 actually you are getting 0. But we have to look into the sign whether it is plus or minus. So it is left limit. So slightly less than minus 2, minus 2.001, minus 2.001 plus 2. Greater number is negative, so your answer is negative. So numerator is negative, denominator also negative, minus into minus it is plus. 4 by 0, something by 0 is infinity. It is plus infinity. Okay, so this sign is important. So I'll teach the right limit also so you can understand better. F of minus 2 plus equal to limit x tends to minus 2 plus f of x is x square minus 4 by x square plus 4x plus 4 into x plus 3, right? Now we factorize it. Limit x tends to minus 2 plus numerator is a plus b into a minus b. Denominator a plus b the whole square, x plus 2 the whole square into x plus 3. Giving limit minus 2 plus slightly more than minus 2. So one part cancel. You give minus 2. When you give minus 2, minus 2, minus 2, minus 4 in the numerator. Denominator, the second factor, minus 2 plus 3, it is 1. When you give minus 2 here, this will be 0, whether it is positive or negative. Slightly more than minus 2. More than minus 2 means minus 1.99, minus 1.999 like that, plus 2. Here the greater number is 2, it is positive, so your answer is positive. Numerator negative, denominator positive, so overall the answer is negative. 4 by 0, something by 0 is infinity, so here the right limit is minus infinity. Right limit and left limit, they are not same, so the limit does not exist, and this is how you have to calculate. Now see the next question, question number 3. Question number 2, evaluate the following limits, so whether the limit exists or not. Okay, so here we have to find both right and left limit. If they are equal, okay, you can say the limit exists, otherwise you say the limit does not exist. Limit extends to 3 minus, let us see the left limit. Factorize x plus 3, right? 9 can be written as 3 square, a square minus b square, x plus 3 into x minus 3 by x square into, this is a minus b the whole square, right? Because a square minus 2ab plus b square, so it is x minus 3 the whole square. You can cancel x minus 3 one time. Now please listen, you are going to give the limit 3. When you give 3 plus 3, 6 by 3 square is 9. 3 minus 3 is 0, but we have to see whether it is positive or negative, right? Actually it's 0, but it is positive or negative. You are giving 3 minus means slightly less than 3, right? Slightly less than 3. Slightly less than 3 means 2.99, something like this. So 2.999 minus 3. Greater number is negative, so the answer is negative. Overall negative. Numerator positive, denominator negative. So your answer is negative. 6 by denominator 0. Something by 0 is infinity, so your answer is minus infinity. Now we see the right limit. Limit extends to 3 plus f of x, that is x plus 3 into x minus 3 by x square into x minus 3 the whole square after factorization. X tends to 3 plus, here you can cancel one time x minus 3. Apply the limit, you give 3 plus 3, 6, 3 square 9. Here only you see 3 minus 3 0, but we have to put positive or negative. 3 plus slightly more than 3 means 3.0001, something like that. Okay, so 3.0001 minus 3, greater number is positive, so the answer is positive. Numerator positive, denominator positive, overall the answer is positive. But 6 by 0, something by 0 infinity, so it is plus infinity. Here minus infinity, so the plus infinity, so you can say the limit does not exist. It's an infinite limit. Okay, now let's move on to another question. Now limit x tending to infinity. Okay, so here you see, if I apply the limit directly, numerator infinity, denominator also infinity, you cannot accept it. So for limit x tends to infinity type questions, so the method you have to study. In the previous video I taught the sums with root. When root is there, you multiply numerator and denominator by its conjugate. So same way, when x tending to infinity, you take the highest power outside, whether it is common or not, take it outside, whatever you can cancel, apply the limit, you will get the answer. That's all. That's a very simple concept. Please listen here. Numerator x cube plus x. Highest power is x cube. Take it outside. If I take x cube outside, 1 plus, we have only x is there. We are taking x cube outside, so you get 1 by x square. You have a doubt, you just multiply and check it. Denominator highest power is x raised to 4. If I take x raised to 4 outside, see what you get? 1 minus 3. X square is there, so here x raised to 4. So another x square you write in the denominator. Plus 1 by nothing is there, so entire x raised to 4 you write in the denominator. If you multiply, you will get it. So now that is limit extends to infinity. Limit extends to infinity. This x cube and x raised to 4, if you cancel, you will get 1 x in the denominator. Numerator 1 plus 1 by x square, and the denominator other factor is 1 minus 3 by x square plus 1 by x raised to 4. Now we give infinity, so when you apply the limit, 1 plus 1 by infinity 0 by, for x you give infinity, right? X you give infinity into 1 minus 3 by infinity, something by infinity, 0 plus 0 So you are getting 1 plus 0. 1 by infinity to 1 infinity. Something by infinity. 1 by infinity, the answer is what? 0. Okay, 0 by a number is 0. Okay, so 1 by infinity is equal to 1 by infinity is 0. Okay, so that's your answer. Now let's move on to the fifth question. Limit x tends to infinity. Limit x tends to infinity. Take the highest power, numerator, take x raised to 4. What's the remaining? 1 minus 5 by, only one x is there, x raised to 4, we are taken outside, so balance x cube. Denominator, x square, highest power, 1 minus 3 by x plus 1 by the entire x square. That is limit x tends to infinity. This x raised to 4 and x square, if you cancel, you will get one x square in the numerator. 1 minus 5 by x cube by 1 minus 3 by x plus 1 by x square. When you give the limit infinity square, okay, so it is infinity. And here this part is 0, right? Infinity into 1. By 1 only, right? Because 3 by x squared. This is 0, this is 0, this is 0, right? Something by infinity 0. So the final answer is what? It is equal to infinity. Now let's see the seventh question. Limit x tends to infinity, x cube by 2x square minus 1 minus x square by 2x plus 1. You can apply the limit, but before that we try to simplify this. See the numerator, x cube is there, here x square is there. You take the common value, you can take x square outside, right? So limit x tends to infinity. If you take x square outside, what do you get? X by 2x square minus 1 minus 1 by 2x plus 1. That is limit x tends to infinity, x square into, you take LCM, 2x square minus 1 into 2x plus 1. So you get x into 2x plus 1 minus 1 into 2x square minus 1. Okay, just to take an LCM. That is limit x tends to infinity, x square into. Multiply term by term. When you multiply, see what you get. 2x square plus x into 1. X minus 2x square minus into minus is plus 1. Divided by 2x square minus 1 into 2x plus 1. Here in the numerator can cancel 2x square and minus 2x square. So limit x tends to infinity, x square into, you get here only that x plus 1 divided by 2x square minus 1 into 2x plus 1. Now you can take common and simplify. Limit x tends to infinity, x square. Here in this bracket x plus 1, highest power is x. What's the remaining? 1 plus 1 by x. Denominator, the first bracket, take x square common, 2 minus 1 by x square. The second bracket, highest power is x. You get 2 plus 1 by x, right? So you can cancel 1x. You can cancel x square. Apply the limit now. Give infinity. 1 plus 1 by infinity 0. By 2 minus 1 by infinity 0 into 2 plus 1 by infinity 0. So you are getting 1 by 2 into 2. So your answer is what? 1 by 4. Okay, hope you understood. Now let's move on to the next question. Show that limit x tends to infinity, 1 plus 2 plus 3 plus etc. up to n by 3n square plus 7n plus 2 equal to 1 by 6. Okay, it is a prove that question. I am starting with LHS. Limit n tends to infinity. It's not x. Limit n tends to infinity. 1 plus 2 plus 3 plus etc. up to n by 3n square plus 7n plus 2. We have to prove the answer is equal to what? 1 by 6. Listen. So limit n tends to infinity. See the numerator. 1 plus 2 plus 3 plus etc. up to n. You studied that, right? Sum of first n natural numbers. What is that? N into n plus 1 by 2. Sum of the squares, n into n plus 1 into 2n plus 1 by 6. Sum of the cubes, the first formula, the whole square. Here, sum of first n natural numbers, n into n plus 1 by 2. This is for numerator. The denominator we have 3n square plus 7n plus 2. That's all. Now just usual method. If you apply the limit directly, you will get infinity by infinity. So limit n tends to infinity, n into, in that bracket you take one n outside, 1 plus 1 by n. Here 2 into, highest power is n square, take it outside, n square into 3 plus 7 by n plus 2 by n square. Now n into n square you cancel. Apply the limit now, 1 plus 1 by infinity 0 by 2 into 3 plus 7 by infinity 0 plus 2 by infinity 0. So 1 by 2 into 3, that is 1 by 6. That is the RHS we are supposed to prove, right? So your answer is 1 by 6. I'll help you one more question of the same type. Listen carefully. Limit n tends to infinity. Limit, I'm starting with LHS. Limit n tends to infinity. 1 by, it is not 1.2, it is 1 into 2. 1 into 2. Plus 1 by 2 into 3, plus 1 by 3 into 4, plus etc. plus 1 by n into n plus 1. So sum of n terms here, right? So I'm using sigma, I'm going right. Sigma is for summation, right? Limit n tends to infinity. You can write it as sigma, the nth term, 1 by n into n plus 1. If you put 1, you will get the first term. 1 by 1 into 1 plus 1, 2, right? If I give 2, 1 by 2 into 2 plus 1, 3. You will get the second term. You will get all the terms, okay? So here sigma n equal to 1 to what? N. Now, this part we have to resolve it into partial fraction. You would have already studied, right? So 1 by n into n plus 1. How can you resolve into partial fraction? This is of the first type. A by n plus b by n plus 1. Take LCM and cancel the denominator or multiply by n into n plus 1. You will get 1 equal to a into n plus 1 plus b into n. To find a value, you put n equal to 0. When I put n equal to 0, you will get 1 equal to a. When I put n equal to minus 1, n equal to minus 1, you will get 1 equal to minus b or b equal to minus 1. b equal to minus 1. Okay, so these values you can substitute here. Partial fraction is one of the very important area. Those who are not thorough with partial fraction, already we have uploaded separate videos, 3 to 4 videos we upload in partial fraction. You can watch that, you will get the clear idea. So we need this partial fraction even in integration. So study that one well. Okay, so now this part we resolve into partial fraction. So limit n tends to infinity. So now we continue. So that is limit n tends to infinity. Sigma n equal to 1 to n. Sigma n equal to 1 to n. See what you have here. A 1 by n in n plus 1. So that we write a by n. A value 1. So 1 by n. Plus b. B value minus 1 by b by n plus 1. b by n plus 1. Listen very carefully. This is something different one. So limit n tends to infinity. Please listen very carefully. Now sigma we are going to apply. Sigma means summation. I am going to give the values now. First n I am going to give 1. Then for n I put 2. Then 3 etc. Finally you put n equal to what? N. So first when you put n equal to 1. 1 by 1 it is 1 minus 1 by. When I give 1 here 1 plus 1 is 2. This is the first term. Plus sigma means summation. Now I put 2. For n you put 2. 1 by 2 minus 1 by 2 plus 1, 3. If I give 3, 1 by 3 minus 1 by 3 plus 1, 4 plus etc. It goes on like this. Then finally when I give n, you will get 1 by n minus 1 by n plus 1. Now please listen here, you can cancel. First bracket, second term, and next bracket, first term, minus 1 by 2 plus 1 by 2. Minus 1 by 3 plus 1 by 3. Minus 1 by 4 plus 1 by 4. It will be here. Same way here, this term and this term. Please listen once again how we cancel. There are so many terms are missing. Just you put etc. But still, how it cancel? One pattern. See, this minus 1 by 2 plus 1 by 2. Minus 1 by 3 plus 1 by 3. Minus 1 by 4 plus 1 by 4. It will be here. Like that it moves on. Then when I cancel this term, the previous bracket, this will get cancelled. So now what is left out? Limit n tends to infinity. First term, that 1 is there, right? 1. In the last term, minus 1 by n plus 1. That's all. All the terms get cancelled. You give infinity now, 1 minus 1 by infinity. 1 by infinity is what? 0. So your final answer is what? 1. Okay, now see, there is a statement sum. Don't be afraid by seeing this question. It looks like some English essay, right? But what we need, our mathematics is here. A function is given r of s. So r of s means it is a function of s. S is a variable here, like our x tending to. So here s is the variable. R of s is s by alpha s plus beta. So s is the variable here, that you remember. Alpha and beta are constants. Show that this fraction, okay, S is sufficiently large. S is sufficiently large. S is sufficiently large. Large means it tends to infinity. So what we have to find here, limit S tending to infinity R of S. And they asked to prove that, show that this function approximately predicts constant. What are the constants here? Alpha and beta are constants. In the answer, some numbers or alpha, beta can come. Okay, limit S tends to infinity. S by alpha S plus beta. Here S is like our x. Okay. So limit S tends to infinity. S by, here you take S common. Like x highest power we take outside, no? Like that only. If I take s outside, alpha plus beta by s. S cancel. So apply the limit. For s you put infinity. 1 by alpha plus beta by infinity. It is 0. So your answer is 1 by alpha, which is a constant. This is what they asked to prove. Prove that the answer is a constant. Already they said alpha is a constant. Very simple thing, that's all. So don't be afraid of the question. So what is required, that you see. Okay. Now I'll teach one more question of the same type. A tank contains 5,000 liters. Okay, whatever. This is our concentration, C of T. So here T is the variable, right? C is a function of T. 30T by 200 plus T. What happens when the concentration, what happens to the concentration as T tends to infinity? It's very clear. So you have to find limit T tends to infinity C of T. This is what they asked to find. Limit T tends to infinity. C of T, 30T by 200 plus T. Since a limit tending to infinity, you take the highest power outside. That's a method, right? So limit T tends to infinity, 30T by, take T common, highest power T only, right? So 200 by T plus 1. So T get cancelled. So when you apply the limit infinity, 30 by 200 by infinity, 0 plus 1. So 30 by 1. So your answer is what? 30. Okay, so it's a very simple thing. X tends to infinity. Take the highest power outside, cancel, then apply the limit, you will get the answer. Okay, so practice more questions. We'll continue in the next video.